All right, parallel lines. Can you guys, I know this is a pain, but you guys mind doing the cube again for me? Draw a cube again, just like we did yesterday for coplanar. And again, how many planes do I have on my cube? 6. Parallel lines have to be on the same plane, but they don't intersect. Okay, so I'm going to look for 2 lines right now on one of those 6 planes, but they don't intersect each other. They'll be parallel. Okay, they'll be parallel. All right, so give me 2 lines right now that you guys would consider parallel on my diagram. Got to be on the same plane, and they have to be, and they do not intersect. Excuse me. Start us off. Madeline, want to start us off?
CF and BH.
CF and BH. Yep, that's on the plane on the right-hand side. So again, line CF and line BH. And I'm just going to introduce this to you now because I know it's going to be coming up pretty soon. Anybody know the mathematical symbol for parallel? So I don't want to have to write the word parallel again. Anybody know? You can try it out.
Isn't it like 2 lines like that?
Like what? Like this?
Mm-hmm. Like that. Or that. Yeah.
Like this. Yes. 2 vertical lines right next to each other, parallel. Yep, that's the symbol for parallel. That's not good enough for me today. Give me another pair. Give me another pair that are parallel up here. 8. Grace, go ahead.
GE and AD.
G, yep.
AD.
You're good. You're good. GE parallel to AD. Good work. Those are parallel as well. Okay, so we got it. As long as they're on the same plane and they don't intersect, you're good to go. All right, real quickly, you guys want to go through this? Go through all. It says name all segments. Can you please just name one for me? AC, what's parallel? Give me another segment that's parallel to AC, EF, and AD. And this is actually going ahead of, because we haven't talked about segments yet. So AC, what's parallel to AC? What's parallel to EF? And give me something that's parallel to AD. What's parallel to AC in this diagram? Parallel to AC, 6. Lucy?
DF.
DF. I like it. Yep, DF is good for me. And I'm going to keep with the line symbol just because I haven't introduced what a segment is yet. That's later on in today's class. So I'm just going to keep with the line symbol for now. All right. I'll introduce segments in a second. EF. What was parallel to EF? Boom. 11. Don't have one. Oh, we were going so good, weren't we, guys? What? We don't even have 19 in here, huh? There we go. 6. Lucy, back again.
BC.
BC, good job. A little school spirit there, yep. And then AD. Get out of the way here. Matthew.
CF.
AD and CF. Good work, kids. Now, if you had any of those reversed, like instead of DF, you had FD, remember, that's fine. The order doesn't matter of those points. All right, so parallel lines, no big deal. Here's where maybe a big deal. I'm going to slow down a little bit. Skew lines. First, let's read the definition of skew lines. Lines that aren't on the same plane. So they can't be on the same plane. They can't be on one of these 6 planes on my die. and they can't be parallel, and they can't intersect. Excuse me? Can we read that again? They can't be on the same plane. They can't be parallel, and they can't intersect. How is that possible? That they can't be parallel and they can't intersect. Ready? I'm going to show you on my die. Can I borrow your pencil? I'm going to hold my die up real quick. Just hold it right there for me. Relax. All right. Okay, ready? Let me show you some skew lines. You got to think of it. Here's the key. You got to think of it in three-dimensional space. All right now, there you go. I don't want your shoulder hurt after this. Okay, everyone see my line right there? See my line right there? They're not on the same plane. Are they parallel? Will they intersect? Not in three-dimensional space, right? Everyone see what I'm talking about? Skew lines. This is a pair of skew lines right here. Okay? They will never intersect each other in three-dimensional space. They're not on the same plane, and they are not parallel. All good? Everyone get the concept of skew lines? Or should I just keep talking to see how long you can hold the die up here? We're all good? Thank you. Great job. Great job. All right.
I need my pencil back.
Oh, you do need that back. Yeah, thank you. Yep. Thought I was going to get away with that one. All right, so here we go. Now that you know what skew lines are, let's see. Can we find a line that's skew to AC in this diagram? Can't be on the same plane, so don't give me AB or BC. Can't be parallel to it, so don't give me DF. All right, and won't intersect in three-dimensional space. Think we can come up with one now? Oh, you want to answer now that you held some stuff up? Rachel, go ahead.
DE.
DE, how's DE look? DE is good. There could be more, but I'll go with DE. So we had AC, DE. This one's going to be behind AC in three-dimensional space. Good. So we'll go DE. How about EF? EF. EF. What would be skew to EF? Can't be on the same plane, not parallel. What do you got, Madeline?
DA.
DA. DA is fine with me. Yep. Good work. Oh boy. Hey, what's skew with AD? Anybody? Go ahead, Kevin. Yeah.
BC.
Let's see. BC. AD and BC. That works. Yep. I thought somebody was going to just go EF on me because that was the answer to the last one. So, but yeah, I'll go BC for you, Kevin. Okay, everyone good with skew lines? We sure? Can't be on the same plane, can't be parallel to the line, and cannot intersect in three-dimensional space. Perfect. Any questions? All right, what do we got up next? Star. And you see the star? Let's keep working on that. All right, lines can be parallel, and so can be planes. Two planes that don't intersect. Okay, they're never going to intersect each other. They don't touch each other. So quickly on my diagram right here, do you think you can identify two planes that are parallel? Because there's only two planes on there that are parallel. Anybody see the two planes that are parallel to each other up here? Here we go, dig deep. I'll go back to my numbers here. 5 spot, which we don't have. Yep. How about 16? Almost. Yeah. 1, almost. Maybe next week. 18. Kayla, what do you got? The two planes that are parallel to each other will never intersect. Name it with 3 letters too. All right, remember, name a plane with 3 letters. Yep, you got the 2 triangles, right? Yeah, you got it. So plane BAC and plane EDF. Yep, those are the only 2 on there I could have picked. Only 2. All right, now here's a more honors level question for you now. How about when is a line and a plane parallel to each other? Okay, when is a line and a plane parallel? Well, you guys, Kayla just found 2 planes that are parallel, right? So what I'm just going to start out with is one of those planes. I'll go plane BAC. That plane will be parallel to the line of the other plane it's parallel to. So go to the other plane, EDF. Pick any line off of it. It'll be parallel to plane BAC. So if two planes are parallel, one of the planes will be parallel to all the lines in the other plane. Hopefully I said that correctly. That made sense. So plane ABC and line, pick any line off of EDF. What do you want? D?
Yeah.
I need a line though, not a point.
I mean DE.
DE? Fine, DE. There you go. Those are parallel. Okay? So if you have two planes that are parallel, any line from one plane will be parallel to the other plane. Is that all right? I think that's a better explanation. If two planes are parallel, any lines on one plane will be parallel to the other plane. We sure we're good there? Yes, no, maybe? Okay, we'll move on. All right, we're done talking about planes, finally, huh? Finally. Now, line segments. I really, really harped on yesterday when I introduced the line to you that it had to have arrows on it, right? Because I said if you don't have arrows on it, it was a new vocabulary term, and here it is. A line segment. That's a piece of a line. Okay, imagine a line without the arrows on it. You got a line segment, right? So let's get a line segment up here. And let's put BC here. So there's a line segment. Instead of arrows, there's endpoints. How do I represent it? With just like, remember how we represented a line with a mini line? Same thing, with a mini segment with the endpoints. The endpoints. Line segment BC, or you could put CB. Now, watch real quickly. Don't write this down. Just focus here, up here. Let's say I put D somewhere on that line segment. I cannot call this line segment BD. This is line segment BD, not the whole thing. See the difference? You need to name a line segment when you write it using the endpoints. Using the endpoints, okay? Not anything in between like a line. Starting to see the difference a little bit? Okay? And that's the symbol for line segment. All good? All right, let's try some, now we're actually going to get in some algebra. Uh-oh. Everyone all right? Nobody scared? Shakes? We're going to get into some algebra. All right. Draw EG. What are they asking me for? What is this? We got to start reading this and make sure we can draw it. What are they asking me for? Draw line segment EG. All right, let's do it. However you want to draw it, horizontally, vertically, diagonally, I don't care. Let's go EG. There we go. Line segment EG. So that means E and G are my endpoints. Point F is somewhere on the segment. Does it say where? Nope. So throw point F somewhere on EG. All right, now notice what happened. EG equals 100. Do you notice here that they dropped the line segment symbol above? If they do that, if they drop the line segment symbol and just put, in this case, EG, they're telling you that's the length. If you don't see the symbol above, they're telling you that's the length of EG. So EG is 100 units long. That's what they're telling you. EG is 100 units long. EF, they drop the line segment symbol, is 4x minus 20. And you can write this on your line segment however you want. It doesn't have to follow my lead. FG is a length of 2x plus 30. Here's what I want. Three-part question. What's got to be the value of x, the length of EF, and the length of FG? Knowing all this information. Okay? Now, this is what I'll get right off the bat. Did we say F was in the middle? Absolutely not. So you can't just say these are equal to each other, I'm done. That's not true. That's not true. But how can I incorporate the 100 to set up an equation to solve for x? That's what I need from you guys right now. Set something up, an equation with an equal sign, so I can solve for x for this first part. This is 2x plus 30. This is 4x minus 20. The whole darn thing is 100 units long. You ready, Grace? All right, let's roll.
4x minus 20 plus 2x plus 30 equals 100.
Done. Perfect. Great job. Everyone see where you got that from? Add the two pieces up. They equal the whole of 100. Uh-oh. Can you solve that? Uh-oh. I don't have time to go over this with you. Combine your like terms. 6x plus 10 equals a hundo. Move the 10 over. And divide by 6. Uh-oh. Should ask to get your calculators out, huh? 66 into 90, anybody?
15.
15. You get 1/3 credit there. I'll give you 1/3 of a credit. Why? Tim?
You still have to solve
You got to read the darn directions, right? I asked for x, yes, but I also asked for the length of EF and FG. So how would I find, now that I know the value of x, how can I find the length of EF? What do you got, Lucy?
Plug in 15 to the x.
Plug and chug. That's what I call it, plug and chug. Take 15, plug it in for x, 4 times 15 minus 20. So what's that, 60 minus 20, 40. So EF is 40 units long. And then I got one more piece, which is FG. Now you got a couple ways to find FG, right? You could plug in x, or because you know it's 100, one piece is already 40, you can subtract if you need to. All right, so 60. Ooh, look at you guys. What's up, Grace?
If you had to find the length of the line segment, would you have to put like the symbol over the like e.g. when you're answering?
Usually when you find lengths, you drop the line segment.
Okay.
Yep, so the answer to that question would be no. All right, yep. That's how you know you're talking length, is when I drop the segment symbol. Anything I can answer for you guys? Star again, wow. All right, I'm gonna end class here on a huge note, because this is something we will be using over and over and over again, guaranteed. And that's this concept of two congruent segments. All right, two segments are congruent if they have the same measure. Okay, if they have the same measure. So watch, here you go. I'm just going to quickly draw two segments for me that look the same measure, AB and CD. Okay. The only way you guys would know if they're the same measure is if I told you how long they were, right? So if I, and please don't copy this part down. If I told you, all right, AB's 3 inches, this is 3 inches, you say, all right, they're the same length, which makes them, what's our new vocab word here? Congruent. That's the only way you guys would know. But I hate to break it to you, I'm almost never going to tell you how long line segments are. Instead, I'm going to start putting markings on them that say that they're the same length. All right. What markings will you see on the line segments that say, hey, these two are the same length? You're going to see what's called hash marks on them. Watch. AB, CD. You will not get the lengths anymore. That's what you're going to get from now on in your book, tests, and quizzes. You're going to get hash marks on there that say, oh, because he put hash marks on A, B, and CD, those are the same lengths, which makes them congruent. Okay, so get used to that, the hash marks, and you guys can start seeing that in the next example. How do I write that they're congruent? It's a symbol. Ready? How do you write this right here? What's this again? Line segment AB. So I say line segment AB. Anybody know the congruent symbol? Oh boy. Okay, try it, Grace.
Is it like those two lines that are like
Just say the squigglies.
The squiggly.
Yeah, it's not
Yeah,
math
fine.
appropriate, but you can say it. This right here?
Yeah.
Close. That's approximate. You're close, close. I need to put something else. Anybody ever seen them? It's the equal sign with one, it's called the tilde, by the way. All right, so if you want to impress people, don't call them squigglies. All right, the tilde. That's the congruent sign.
Matilda?
Tilde. Yes, that's what that one little thing here, that's what that's called, the tilde. Yep, if you want to impress anybody.
With multiple.
This here,
Yeah.
that's approximate. Like the answer is approximately, X is approximate, like if you had to round something, X is approximately 2.25. So again, this is the symbol for congruent. And then congruent to line segment CD. That means they have the same length. Okay, they have the same length. All right, let's go to example 1 here. I'm going to let you think about this yourself before we end class. Use the markings on the diagram. Which one of these choices is incorrect? So first, look at the diagram. What do you already know about the diagram? Just by the markings. Just by my hash marks. What do you guys already know? A, B, and C, D are congruent, which means they have the same length. Just by those markings. Everyone see it? I can see the hash marks on A, B, and C, D. That means they're congruent, which means they're the same length. All right, if that is true, which one of these is incorrect? Incorrect. Okay, let's see if we can figure it out. I'm not going to call on anybody, but I want you guys to think about it and see if you have a choice in your mind. Okay, ready? Is AB congruent to CD?
Yeah.
Yeah, that's what the markings say, right? That's why I put those hash marks in. That means they're congruent. Now, notice number 2. I dropped the symbol, so that means is AB the same length as CD? Yeah, why? Because they're both congruent. That's what congruent means, that they're both the same length. So 1 and 2 are perfect. All right, now we get a little crazy. How about 3? Do you think AC is congruent to BD?
Yes.
Oh, you think so?
Yeah.
Anybody want a little explanation? How do you know that? Explain yourself. How do you know? Go ahead, Grace. How do you know?
Because if the two segments are congruent, then A would be the same distance from C than B is from D.
Yes. Ready? Here's my question. What do you have to add on to AB to get to AC? Line segment AB. What would I need to add on to it to get to AC? AB. What do I need to add to it to get to AC? BC, right? Everyone agrees I need to add on BC. Ready? What do I need to add on to CD to get to DB? BC, right? You're adding the same thing to both. Does everyone see that? So if these are already equal and you're adding the same thing to it, shouldn't the results also be equal? Yep. So which one's incorrect? AC is not congruent to CD. They are not the same lengths. Okay? Not the same lengths. All right, you guys good? Okay, you got plenty of time. You can grab a textbook if you want to borrow one or open up your Chromebooks. You guys can get started on, yep. Thanks for turning that over, Lucy. Half the homework's in your packet right now. The other part's in the book, remember, all right? It's down at the bottom of page 8, all right? Part of it's page 9, other part's in the textbook. All answers up on Classroom as usual.